Second page, question 4 had three parts, A, B, C. The instructions were to solve for y. As I look at this first equation, there's a couple things that strike me. The first is that on the left-hand side, I do have a binomial times a binomial. And I typically like to structure polynomial multiplications using a generic area model. Um, it's extendable to any, n by n, like a trinomial times a trinomial, or anyways. I'll place a y plus a 3 here and a y plus a 2 here and fill in the generic area model. This ends up being a y squared. This is 2 times y. The area of this is 3 times y, and the area here is 6. So if I look at those four areas of values that contribute to the product there, I can see that there's a y squared, and then I have plus 5y. When I combine the 2y and the 3y, it gives me 5y. Then I have a plus 6, and then if I continue with the problem, then there's plus another additional 5y. So that's the left-hand side. And I want to clean that up a little bit more. I'm just going to write this as y squared plus 10y plus 6. So when I combine this 5y with the 5y that I get from this product, there's 10y there. On the other side, a couple different things going on. There is this negative value that I need the opposite of this binomial, so I need to be very careful to distribute this negative, and I can put a 1 here if it helps me, but I need to distribute this negative to both of these terms. So I'll start with the 21. So I have 21, and then I'll rewrite this as minus 2y and then plus the number 7. So again, this is indicating that I need to take the opposite of this binomial. So both of those changed in sign. It became a negative 2y and then a positive 7. And then you can see there is a minus 10 and then plus a y squared. So if I look at this and attempt to simplify this, I can see that there's a 21 and there is a minus 10, which would give me, if I combine those two, the 21 and the negative 10 would give me a positive 11. And then there's this plus 7. So I can take all of those and write them as just the number 18. The other thing that is here is there is a negative 2y and there is also a y squared on each side. So fortunately, both sides have a y squared, and I'm going to subtract that from each side. This is not a quadratic, and we don't have to deal with that right now. When I subtract y squared from both sides, it becomes 10y plus 6 equals 18 minus 2y. I guess I'll take away 6 from each side, so 10y, 18 minus 6 should be the number 12, and then minus 2y. I'll add 2y to each side, so 12y is 12, and then y is just 12 over 12, or y is equal to 1. So I have what I believe is my solution for y, and when I'm if I'm taking a test or if I'm creating a key, it's always a good idea to run through and just verify that that does produce equality, that it does make both the left and the right hand side the same. And I'm not in a hurry doing these videos today, so you can skip past this if you're not interested, but my claim is that y is 1, and I want to verify that claim, and I'm going to do so by plugging the number 1 into both the left and the right hand side. So let's look at the left hand side first. Turn on the calculator, I'll clear it, and I'll just do open parentheses 1 plus 3. Yeah, I got that, that's 4. Close parentheses, and I've got 1 plus 2, and then plus 5 times 1. That's 5 times what y is. So when I do that on the left hand side, all of this becomes the number 17. So let me as a reminder, I'm just going to put over here, this all becomes the number 17. And my question is that the same value over on the left-hand side? If it is, I have my solution. If not, I need to start trying to figure out where the heck I made my error. So let's plug in these numbers onto the other side. So I guess I'll drag this over here. So it says I've got 21, and then I'm going to subtract, open parentheses, 2 times y, which is 1, minus 7, close the parentheses, minus 10, and then plus 1 to the second power. I'll just put it. And as soon as I press enter, I can see, yeah, that makes 17 as well. So this y is 1 is a solution, not because I had nice handwriting, although I am pretty proud of that. It looks good for me. Not because I showed a lot of work or a lot of steps. The reason why the solution is y is 1 at the end of the day is because that's the value that makes the left hand side and the right hand side equal. And short of that observation, it's not a solution. But y is 1. I really encourage you to check your work like that. This is part B of question 4, and again the instructions were solve for y. What I'm observing is that there are both x's and y's, so my solution here is going to be an equation, and probably in slope-intercept form. So as I observe across this, I can see on the left-hand side on the right-hand side, I am able to combine both the negative 6y and the positive 2y. So if I rewrite that, this will become 12 minus 4y plus x. And over on the right hand side, I'll just rewrite the 3x plus 4y. I think I'm going to go ahead and add 4y to both sides. So when I add 4y to each side of the equation, over on the left hand side, this becomes 3x plus 8y. And on the right hand side, I have 12 plus x. I think the next thing that I'm going to do is from each side I'll subtract 3x. And that's going to give us 8y equals 12 and then minus 2x. And then the last thing I could do is divide both sides by 8. Two ways I can do that, right? I can show this, which is saying I need to divide that entire denominator by 8. But I can also divide each one of them separately by 8. I can write this as 12 over 8 minus 2x over 8. And honestly, that's a fine answer. I can process that. I can look at it. But it's really a good idea to simplify things. And also, I'm going to switch the order of these two terms so that it looks like it's in slope-intercept form. So 2 over 8 is a fourth, right? So this is y equals, notice it is negative. So I'll say negative 1/4 and then just timesing by x. And then if I reduce the 12/8, both of those can be divided by the number 4. If I divide 12 by 4, I have 3, and if I divide 8 by 4, I have 2. So this is the equation that I think, I would have taken other forms of it, but y is negative 1/2 x plus 3/2. And then finally for part C, I have an equation that does have y. It's just one value of it down in the denominator, and clearly this is a prime example of fraction busters. So I am going to go ahead and multiply both the left and right hand side by a value designed to eliminate all of the fractions that I see here. So in this case, what I'm going to multiply both sides by is 10 times y. 10 times y. Oh, it's not 10 over y, my bad. 10y over 1. So if I rewrite this, the first thing I have is the 3 over 5, but I'm bringing in 10y. And then I'm adding 3 over y, but let's not forget this is also going to get a 10y factor. I don't like how that looks. Times 10y. And then finally this will equal 5 over 2. And again, this needs an introduction of the factor 10y. So it's important to see this. Every single term on both the left and right hand side picked up a factor of 10y. Now, as I go through and I look at it, this was designed to simplify. There's a lot of simplification that can happen. This first term, 10 divided by 5 is 2. And if I multiply that by 3, I'm left with 6y. So my first term is 6y. The next one, you can see there's a y in both the numerator and denominator. They will cancel and I'm left with 30. And over on the other side, 10 divided by 2 is 5, and 5 times 5 is 25. So this becomes 25y. So you can see that this is quite a bit different looking than the equation we started with, right? I no longer have any fractions at all to deal with. I can take away 6y from each side. That would give me that 30 is, I believe that's 19. Yeah, 25 minus 6 is 19y. And if I divide both sides by 19, 30 19ths is the value of y. So here's y. It's just 30 divided by 19. And it's not that difficult of a process to check that answer. So if I look at it, in fact, I'm going to try the fraction key on this one. So I'll hit second alpha, grab the fraction. I'm going to do 3 over, not that. I wanted to do 3 and then over 5. Interesting. Plus, and then I'll do the, I'll do the fraction again. And I'll do 3 over. And I want to see what this does. I'm going to put a fraction in the denominator. Second, nope. I got to quit that. Second, quit. Let me try that again. I'm feeling very comfortable with this calculator. Let's see, second fraction. I did do it. So I'm going to put 30 and then over 19 because that's what I believe y is. And when I press equals, I should get the number 5 halves. And at 5 halves, it goes in, it's 2.5, right? So this should say 2.5 when I press enter, and oh, that's nice. It expressed it as a fraction, which is great because when I put this answer into this, right, when I put in that y is 30 over 19, it made both the left hand side became 5 halves and the right hand side was already 5 halves. So it clearly is the solution to this equation.